Hello everyone, I hope that you all are doing well. Today we solve a very interesting question. This question is asked in GATE 2024 in mathematics. Okay, and this question is from functional analysis part, mainly from the inner product space or from the Hilbert space. Okay, what is given? L2 minus 1 comma 1, this is a Hilbert space. Okay, Hilbert space means complete inner product space. Okay, and P1 is a subspace of P1 is a subspace of L2 minus 1. What is P1? P1 is a set of all collection of all the polynomials. P1 is a span of 1 comma x, means it is the collection of all the polynomials whose degree is less than or equal to 1, whose degree is at most 1. This is mentioned. Okay, this is the P1 span of 1x. So P1, if we write it explicit form, P1 looks like a0 plus a1x, such that a0 comma a1 belongs to the scalar field. What is the field? Scalar field here? For the simplicity we take r, because why we have taken r not c? Because it is mentioned that L2 space is a real valued functions. Okay, for that reason we are taking the scalar field r. If it was complex valued, then we should take c. Okay, because p is a subspace. Okay, p cannot contains the polynomials whose coefficients from complex, means it cannot be complex valued. Okay, since L2 given that is a real valued functions. Okay, so scalars are from the real numbers. Okay, I hope that you all understood it. Okay, now what is asking is about infimum of g belongs to P1 such that f minus g norm square. Okay, norm square. What is the infimum value of this? What is f? F is a function from L2 minus 1 to 1. F is given that f given f is a function from L2 minus 1 to 1. F lies in this space. Okay, and what is asking? If you look geometrically, what is asking? If this is the P1 space, this is the P1 space. Okay, and this is f. Okay, this is a function f. Okay, then it is asking what is the minimum distance square. Distance is the norm. F minus g norm means it's the distance function. Okay, distance function. If we understood it geometrically, what is actually asking? What is the here g functions are like g1, g2 in the P1 space. Okay, means these are polynomials, all the polynomials whose degree is at most 1. Okay, and what is asking? The minimum distance. Minimum distance is what? Minimum distance is actually the perpendicular. If you find such g naught which is equal to which minimizes this norm, then it should actually perpendicular to this space. This is the P1 space, and this functions f minus g naught should be perpendicular to the space P1. Means actually this function L2 space is an infinite dimensional space, and we are approximating this function by finite dimensional space. This is the finite dimensional space. What is the dimension of the P1? Dimension of P1 is 2. Here two elements are forming its basis. Okay, so we are actually approximating an infinite dimensional function by the finite dimensional subspace. Okay, this is a geometrical concept, but we will approach to solve it theoretically. Before solving this problem, first of all, known what is given data. Given data are that f norm square, it is the given data f norm square, and this one is your 3 data are given. Okay, 3 things are given. First let me write the 3 things. What is given? F norm square. F norm square is given that 18 by 5. Okay, 18 by 5, and integration minus 1 to 1 fx dx is equal to 2. Integration minus 1 to 1 fx dx equal to 2, okay, and integration -1 to 1 x fx dx is equal to 0. These things are given, okay. X dx is equal to 0. Actually what is given, if you, it is the norm square, okay, it is no doubt it is given, but it is giving if you look it in a different way, then it gives nothing but the -1 to 1 fx dx is equal to 2, means what? Means if you look in a different way, it looks like fx into 1 dx equal to 2, means it is the inner product. Inner product is defined in the integral in this way, means f this is nothing but the inner product of f comma 1 equal to 2, okay. This is the nothing because inner product f and g, fg inner product is defined in this way, integration -1 to 1 fx gx dx. This is the definition of the inner product. Here f is our f and g, in place of g it is the 1 function, polynomial 1 function, okay. So if we will write in the second condition, this condition in this way, then what is it will looks like, it gives the f into x inner product equal to 0, okay. So if we will write these things in a simple way, okay, let me erase these things. I hope that you will understood it. Then this condition looks like f inner product 1 equal to 0, and this condition looks like f inner product x equal to 0. These two things are nothing but the basis element of the P1 space. Did you get my point? I hope that you get my point, okay. These are the basis elements, okay. These two data and these things, by using these three data we can solve the problem, find the minimum g, g naught. Our target is find the g naught whose distance from f is the minimum, okay, and g varies in the P1 space, okay. Let us solve it. Means we have to calculate this thing na, okay. Let us solve this thing, okay. Let d equal to minimum of g belongs to P1 f minus g norm square, okay. Before going to calculate, first of calculate this term. What is this term, okay? f minus g norm square, okay. f minus g norm square is nothing but what? We know that if x norm square is written as x inner product, okay. This is the definition of the inner product. Norm square can be written as this one. Norm is defined in terms of, if you define the norm in terms of inner product, it looks like this. If we will apply this definition, what we will get? We will get f minus g inner product and f minus g inner product, okay. It gives what? It gives f, if we will open it, f comma f inner product minus 2 times f comma g inner products, because it is commutative, and plus g comma g inner product, okay. But g lies in what? G lies in P1 space. So g looks like in this way, g equal to a naught plus a1x, okay. Definition of g, if g is a element in P space or P1 space, is a P1 space, okay, it looks like a naught plus a1x, okay. So g equal to a naught plus a1x, okay. So it gives what? It gives f minus g norm square is equal to, actually what? It gives f comma f inner product is f norm square, okay, and minus 2 times f comma if you replace g by a naught plus a1x, a naught plus a1x, okay, a1x inner product, not bracket, these are inner products, and it gives plus g norm square, g comma g inner product is g norm square, okay. And in our question, what is given? That what is f norm square is 18 by 5, okay. So it's gives 18 by 5 minus 2 times, if we will, inner product is linear, okay. So in the second second bracket, if you will open it by using linearity condition of inner product, it gives what? F comma a naught minus 2 times f comma a1 x. Okay, a1 x plus g norm square. G norm square is what? G norm square is g comma g inner product. Okay, so it is better to write g comma g inner product, not g comma g inner product. Okay, g comma g inner product. Let us for the simplification, let us count, let us first of all find these terms. What are the values of the term, these three terms? Okay, individually, because I have less space in my I have less space in my tablet, so for that reason we are calculating these things separately. Okay, first of all calculate f comma a naught inner product. Okay, f comma a naught inner product is what? A naught is a scalar, so it comes out a naught scalar f comma 1 inner product, and the value of f comma 1 inner product is given what? This is, oh, I have mistakenly written it 0. It is not 0. It is f comma 1 inner product is this one now, it is 2, and f comma x inner product is 0, it is given 2. Okay, so it gives 2 a naught. Okay, now we will calculate f comma a1 x inner product. Okay, what is its value? A1 is a scalar. Okay, so it comes out but it is a real scalar, so it gives the conjugate, but in the real number conjugate is same. Okay, so a1 f comma x inner product, but we know that f comma x inner product is given that what? It is 0. Okay, so it gives 0. At last we have to calculate g comma g inner product. G comma g inner product is what? G is what? G is a naught plus a1 x comma a naught plus a1 x. Okay, these things, so it gives what? A naught inner product, a naught plus 2 2 times a naught inner product a1 x, these things. Okay, plus a1 x inner product a1 x. Okay, if we will calculate it, it gives what? It gives a naught square. Okay, a naught square plus 2 a naught a1 gives inner product of 1 comma x plus a1 square x comma x inner product. Okay, these things will come. Now we'll calculate a naught square plus 2 a naught a1. It gives what? It gives the integration minus 1 to 1 into x means x dx. Okay, if you write 1 into x dx. Okay, and it gives a1 square integration minus 1 to 1 x square dx, x into x square dx, but this is an odd function, or and it is integration from minus 1 to 1, so this term vanish. Okay, so finally it gives a naught square plus a1 square. What is it gives? X cube by 3 minus 1 to 1. Okay, if we will calculate it, simplifies it, we will get a1 square plus a naught square plus a1 square. It gives what? 1 by 3 and minus 1 by 3, and it minus 1 by 3 minus of minus 1 by 3, so it gives 2 by 3. Okay, so if we will write it correct way, it gives 2 by 3 a1 square. Means we have calculated these three terms. Okay, if we will put the values of these terms in here, we will get what? If we will put these values here, okay, in these terms, okay, we will get f minus g norm square is what? F minus g norm square is 18 by 5. First term is 18 by 5. Second term is what? Second term is 2 f into a naught. F into a naught is 2 a naught. Okay, this is 2 a naught. F into a naught, 2 a naught, already 2 is there, so it is gives minus 4 times a naught. Okay, so it gives minus 4 times a naught. Okay, and what is the, okay, This is the second, first term is 10, second term, third term is minus 2 times f into 1x, minus 2 times f into 1x, it gives the 0. And third term is a g norm, g into g inner product gave the these two terms. Okay, so it gives plus a naught square plus 2 by 3 a1 square. Okay, so finally we got this thing. But what is our target? Our target is to find d equal to minimum of g belongs to p1 such that f minus g norm square. Our target is to find this one. But this thing can be converted, this minimum value can be converted to minimum. If you looked that here terms are a0 and a1. Okay, a0 and a1 are varies instead of g. So we can write this term in equivalent form. It gives what? It gives minimum of a0 comma a1 belongs to r. These are varies in real numbers. Okay, gives what? 18 by 5 minus 4 a0 plus a0 square plus 2 by 3 a1 square, these things. Okay, so it gives what? Minimum of a0 comma a1 belongs to a real number. These are the a0 and a1 varies in real number. If we will write in a simplified way, it gives a0 square minus 4 times a0. Wait, I think I have made some mistake. Let me check, because here it is coming a0 square. Okay, maybe I have done some mistake. A0 square. Okay, let me check. Oh, got the point. Here I have mistakenly calculated a0 and a0 inner product is a0 square. I have written this way is mistake, because a0 comma a0 inner product is what? Integration minus 1 to 1 a0 square, a0 into a0 into a0 dx. So it gives what? It gives a0 square integration of minus 1 to 1 dx. So it gives 2 a0 square. So I have written mistakenly that it is a0 square. Okay, so it gives 2 a0 square. Okay, so finally if we will put it is not a0 square, it is 2 a0 square. Okay, so it gives what? 2 a0 square, this minus 4 times a0 plus 18 by 5 plus 2 by 3 a1 square. Okay, these things are coming. So means so we have made that mistake here. Okay, 2 times a0 square is coming, so it gives 2 times a0 square, 2 times a0 square. Okay, so we have corrected these things. Okay, now let us calculate this minimum value of this. Okay, minimum of a0 and a1 belongs to. How to calculate the minimum of these things? Okay, minimum of these things calculated. To calculate the minimum things, we apply the class 12 algebra. To find the minimum value of the quadratic equation, we have to convert it in square form. Okay, mainly square form means if we take 2 common, it gives a0 square minus 2 times a0. So we are converting it to 2 into a0 minus something, so whole square form. So we have to add and subtract plus 1. If we look, we have added 2 times 1, so we have to subtract it. Minus 2 plus 18 by 5 plus 2 by 3 a1 square. I hope that you get it. Okay, so it gives what? Minimum of a0 comma a1 belongs to r such that 2 a0 minus 1 whole square. If we will add this sum, what it gives? It gives 18 minus 10, so it gives 8 by 5 plus 2 by 3 a1 square. Okay, so when this sum is a minimum, if you look this sum, these all quantities are non-negative quantity. It is also in square form, it is non-negative, it is also non-negative quantity, and it is also non-negative quantity, but this is a constant quantity, we cannot minimize it. Okay, in our hand we can minimize this term and this term. This term gives the minimum value 0, and this term is also given minimum value 0. At which point? It is at a not equal to 1 and a 1 equal to 0. At these points it gives the value, minimum value, and the total minimum value will be what? Total minimum value will be, this term is 0 and this term is 0, so it gives 8 by 5. If we will write in point form, it gives 1.60. this is the answer. Okay, I want to add something more, because in this question it is asking the minimum norm, means the minimum distance. We got this minimum distance, these things, or in question this thing is got 1.60, but it also sometimes asks what is that minimum function, minimum g naught, what is that required g naught which minimize this thing f minus g. How can you get that minimum function? If you look carefully, that you have already calculated that minimum functions, because you have calculated a naught equal to 1 and a 1 equal to 0. Okay, so g is equal to what? G naught is equal to a naught plus a 1x, and you have calculated g naught is what? 1, and a 1x is, a 1 is 0, so 0 into x, so 1. This 1 function minimizes that distance. Clearly, if you look that this 1 g naught function is also perpendicular to f minus g also. If you look that, you should verify it by yourself geometrically. Okay, if in the question if ask this function also, you can explicitly calculate what is that minimum g in this space P1, mean g belongs to P1 such that which minimizes, g belongs to P1 f naught minus f minus g norm square. This is the minimum. What is the value of g which minimizes? That g naught is nothing but 1. Okay, I hope that you all understood it very well. This is a very nice and interesting questions from functional analysis. I hope that you all enjoyed it. Thank you all.